All right, we're going to be working on surface area of these same type of shapes, okay? So the first slide that you guys like is here. Surface area volume is the inside, surface area is the outside, okay? So for example, if we're working with this prism here, we have to add up all of these pieces, okay? Well, if we folded it out, we call this a net, okay? Then this side 1 that we see is right here. Side 2 is right here, the top is right there, and then we can't see, this is that right side that's over here, the bottom we can't see, and then this is the back. Okay, and these types of things, it's all about being able to visualize what you're seeing, okay, that you're adding up each of the sides. Okay, we have a video here that can show this a little bit better.
We're going to talk about nets. If I have a volume or a prism here, okay, and I needed to find the surface area of this prism, and I was actually holding it, I would physically measure each side. I would measure, okay, the top, got to make sure that's right, and I would just go base times height, and then I would go to side 1, and I would go base times height. Okay, the problem, though, is that most of the time you're going to be given something on a sheet of paper that's two-dimensional, and that makes it difficult. So what we have to do is be able to understand what does this shape look like if we what we call a net. So what happens is it opens up into a 6-sided object because the shape itself has 6 sides. And now, just like before, we have the same numbers on it. Well, there's the top of where we started. That was the outside piece here. Here was the bottom. That was that outside piece here. This was the 1 side, 2, 3, and 4. So as you can see, if it folds up into a shape, still the same shape even if it gets folded out. That's what we call a net. And you need to be able to understand what it's like to draw a net out into a shape. That also works for cylinders, although it's a little bit harder to see. On a regular cylinder, okay, we have the bottom side, got to figure out how I typed it there. We have the top side there, and we have the circumference. As you can see, I wrote it around. Circumference. It's all the way around the circle. Okay, if I then fold this figure out, okay, the circumference becomes a rectangle. Okay, here it's just a circle. It's winding around the circle itself. But as it folds out, it becomes just a regular rectangle. And then the bottom piece, there we go, bottom piece is a circle that sits on top. And the other one, there we go, the circle that sits on bottom. So it actually becomes a rectangle with 2 circles attached to it. Okay, so that's what a net looks like for these types of shapes. You'll have to do that at the end of the assignment.
Okay, so for example, if we're trying to find the surface area of this cube, okay, this part right here, well, this is the base here, and the height is 3. So that piece right there, or this blue piece, would be 9. Okay. Well, this red part right here, that's also 3 times 3, so that would be 9. The yellow part up here, once again, that's 3, so this would be 9. And we know that the blue here in the front and the blue in the back, like here, are the same thing. So this is also 9 for the front and the back. We know the red and red, those are going to be copied, so that's 9. We know the yellow, top and bottom, are going to be the same, so it's 9. So it's adding up 6 9s for these cubes. Well, that's 27. And that's 27. And so it's 54 inches. And now since it's surface area, since it's a flat surface, it's two-dimensional, so inches squared. Volume's cubed, surface area is squared. Okay, the idea is seeing that net, seeing what all the pieces are. So I want you to try this one on your own. You got to find the surface area of this one, and then that's front and back. This one, that's right and left, and the top piece and the bottom piece will be the same. Okay, so for this one, the front and the back, that'll be 18 times 5, which would be 90, I think. Yep, 90 total. And so left and right. Okay, so that's 8. That's times 18. So 18 times 8. This would be 144. We got a double 144 that gives us 288 for left and right. And then top and bottom, that's 40, because that's 8 times 5, and that's 40, so that gives us a total of 80. So to add them all up, gives us a total of 458, and this will be centimeters squared. Here's the same idea, okay, except the difference here is that in order to create this, you have two pieces. You have the front and you have the back, and then you have this long rectangle, like the cylinder. And so the idea is we got to do the front and back. So that's going to be a height of 3 and a base of 1, so that's 1 times 3 divided by 2 equals 1.5. Well, that's the front, and then the back is 1.5. So those two are both going to be 3 together. But in order to get this long piece here, you have to do the perimeter of this front, and because it's repeated, you have to take it times the depth. So the perimeter of the front, if this is 2, that'll be 2. So 2 plus 2 plus 1 is 5. And we have to take that times the depth, because it's repeated for 10 full centimeters, and that's 50. So the surface area of this piece is going to be the front and the back added together, which we found to be 3, and then the perimeter of that front piece repeated will give us 50. So this one is 53 centimeters squared. Well, cylinders are going to be the same. The idea is here you're taking 2 times a base, or right there, and then you're going to take the circumference or perimeter times this depth here. Okay, so it's the same idea. Well, we know that if this is 4, that means the radius of the front piece is 2. So the area of this is going to be 2 squared times pi, which will be 4 pi. Well, since there's 2 of them, we got to multiply it by 2. So 8 pi. That's top and bottom. Now, we need the perimeter of this piece multiplied times this depth measurement, which is 8. So we need circumference times, or diameter times pi. So over here, it's going to be 4 pi times that depth, which is 8. So that's 32 pi. And now now we have to add those two pieces together, and we get a total of 40 pi, or if you multiplied that out, it would be the same thing. Okay? Remember, it's that top and bottom, or front and back, depending, and then the perimeter times the depth. If we did these types of shapes, you could do the same thing, actually. You could do the front and back, that's 9 plus 9 is 18. The perimeter is 3 plus 3 plus 3 plus 3 is 12, times the depth, which is 3, gives us 36. 36 plus 18 is 54. So that would work as well. It's just here it's easier to add each piece up. So remember, always that perimeter, that front. I want you to try this one on your own. Okay, the radius of that top part is 12, and it's got a total height of 40. Find the surface area. Okay, so for the top and bottom, it's going to be 144 pi for each. So it ends up being 288 pi. The circumference of that top part is going to be 24 pi times the height of 40. So that's 24 times 40 is 960 pi. And now we just add those up. 960 plus 288 is 1,248 pi. And if you multiplied that out, it'd be the same thing. Okay, and the label here is going to be feet squared. And that's the surface area. Surface area is the outside. Volume's the inside. This takes practice. Okay, so we're just going to take a couple days and make sure we really get this on lockdown. Okay, if you need help, by all means, ask me. This is a hard one to do in a video. Okay, that's the book assignment, but I also have an IXL page, which I think is a little bit better for these. Okay,